echelon matrix. So a matrix is said to be row echelon matrix. Then it has to satisfy three conditions. What are those conditions? Leading element of each row must be unity, that is 1. If 0 row is present, then it must be at the last. In each row, numbers of zeros must be more than the previous row. These are the three conditions. Now, we are having 4 examples. We'll check whether they are satisfying the conditions of row echelon matrix or not. Now, let us check the first one. See here, leading element of each row must be unity. Leading element. See here, 0 not leading element. Here, the leading element is 1. Okay. Next, leading element is 1. And here, there is no element only. Okay. If there is element, it has to be 1. So, there is no element. Therefore, the first condition is satisfied. Next, if 0 row is present, then it must be at the last. 0 row means all the elements of that row are zeros. So, here 0 row is present and it is at the last. Therefore, second condition is also satisfied. Next, in each row, numbers of zeros must be more than the previous row. See here, this is the first row, so there is no previous row. Consider this row. There are 2 zeros. Okay. In the previous row, there is only 1 0. So, more than the previous. Next, here are 4, the previous 2. So, more than the previous. Therefore, third condition is also satisfied. Therefore, this is row echelon matrix. Coming to the second matrix. See, leading element of each row must be unity. So, here the leading element is 1. Done. Next, here zeros. The leading element is 1. Okay. And here the leading element is 1. So, first condition is satisfied. Next, if if 0 row is present, then it must be at last. Do you find any 0 row here? No. Okay. So, if 0 row is present, then only it has to be in the last. It doesn't mean that there should be a 0 row. No. So, there is no 0 row. So, the second condition is also satisfied. Next, in each row, numbers of zeros must be more than the previous row. Here, the numbers of 0, 2, and here there is no row. So, more than the previous. Here 3, here 2, so more than the previous. Therefore, the third condition is also satisfied. Therefore, it is row echelon matrix. Next, coming to this first condition, a leading element of the row must be unity. See here, leading element 1, and here leading element is not 1. Here leading element is 1. Okay, so the first condition itself is not satisfied. Okay, now let us, of course it is not row echelon, but let us see the second condition. If 0 row is present, then it must be at last. There is no 0 row. Of course, this is satisfied. Second condition is satisfied. In each row, numbers of zeros must be more than the previous. Here 2, which is not more than the previous. Here 2, which is not more than the previous. So, out of 3 conditions, 2 are not satisfied. Even 1 is not satisfied, then it is not row echelon matrix. Therefore, this is not row echelon matrix. Coming to this, leading element has to be 1. Correct. And here there is no element, no problem. Here the leading element is 1. Therefore, the first condition is satisfied. Next, 0 row. If there is 0 row, yes, there is 0 row, but it is not at the last. Therefore, second condition is not satisfied. Next, the third condition, number of zeros must be more than the previous. 3 more than previous. 2 not more than the previous. Therefore, this is also not row echelon matrix. So, this is about to get to know whether the given matrix is row echelon or not. Reduced row echelon matrix. It is written as reduced row echelon matrix of, like this it is written, reduced row echelon matrix. So we got to know how to find out row echelon matrix. Now we have to know how to find out reduced row echelon matrix. See, when the matrix is being given, then there is only one condition, that below and above the leading element there must be 0. What is leading element? We know that in the leading element in the row echelon matrix is nothing but 1. So see here, leading element, below leading element it is 0, correct. Here leading element 1, above and below there must be 0. So the condition is satisfied. Therefore this is reduced row echelon matrix. Next, here leading element, below it is 0. Okay. Here above and below 0, and here above 0. Therefore this is row echelon, reduced row echelon matrix. Here 1, below it there is 0. Okay. Here 1, below it there is 5, above 0. So above is correct and below is 5. Therefore this is not reduced row echelon matrix. Next, here below 0. Okay. And here above and below 0. And here above is 4. Therefore this is also not reduced row echelon matrix. When the matrix is row echelon form, in the row echelon form, then how to find out its rank? This is very important question. Find the rank of a matrix by echelon form. If this is the question, how to find out the rank? See, this is the matrix given. First, you need to reduce it to the upper triangle matrix. So, upper triangle matrix means what? The elements below the principal diagonal, you have to make them zeros. Now, how to make them zeros? First, 2. You can multiply it by 2. 2 minus 2 becomes 0. So, R2 has to be R2 minus 2 R1. Next, what about this? R3 can be R3 plus R1, because minus 1 plus 1 becomes 0. Now, write it. R1 as it is. Now, this is R2. 2 minus 2, 0. 2 minus 8, that is minus 6. 10 minus 16, minus 10 minus 16, minus 6. Minus 1 plus 1, 0. Minus 2 plus 4, 2. 6 plus 8, 14. Okay, now, the remaining element is, okay, these two became zeros. Now, this has to be 0. So, how to make it? See here, in order to make it very simple, okay, I will divide R2 by 6, or you can divide it by minus 6 also. Next, R3 I will divide it by 2. Now, what it becomes? 1, 4, 8, okay, 0, 1, 1. Divided by minus 6 means 1. Next, 1, and this is 7. So we got it in the simple form. Now, this has to be made 0. 1 minus 1, very simple. So, here R3 should be R3 minus R2. Now, write it. So, A becomes R1, R2 as it is. So, 1, 4, 8, okay. And 0, 1, 1. 0, 1, 1. Now, what has to be R3? R3 minus R2. 0 minus 0. 1 minus 1. 7 minus 1. Okay, so this is how we got the upper triangle matrix. After this, we can find out rank. Rank of the matrix A is nothing but number of non-zero rows. Non-zero rows means there should not be any zero row. Non-zero row has to be present. So this is non-zero row, and this is non-zero row, and this is also non-zero row. So how many non-zero rows are there? That is 3. Therefore, the rank of this matrix is 3. This is how it is very easy to find out the rank of a matrix by the Echelon form. First, reduce it to the upper triangle matrix, then count the number of non-zero rows. That has to be the rank of the matrix.